Welcome to this video about Unium. Unium is a library for Unity that lets you interface with your game remotely. This can be useful for things like automated testing and debug visualization. In this example, I have the game running on the right, and I can use my browser on the left to make a call to get some basic information. This is returned as JSON data. The code for this is very simple. There is a basic router object, with which I register a function, and this function is invoked to handle any URL that starts with the string about. The handler function takes the request object that it uses to return some data. In this case, it uses a bit of reflection to turn a C# object into a JSON string. Or if we prefer, we could return binary data. For example, taking a screenshot and returning it as an image. So that's the basics, but the real power comes adding a query language and WebSockets. For the following examples, I am going to use the tutorial scene that you can find in the GitHub repository. This is a simple game that has a little yellow player and some spinning collectible coins, and these all live under an object called game that lives in the root of the scene. So, as the game is running, let's go back to the browser. Unium implements a query language called GQL, which is a little bit like XPath. GQL searches a virtual tree, and one of the nodes in this tree is the scene. Access to the scene is via the URL /q/scene. This returns some information about the objects in the root of the scene. Now, say we wanted to find the player. We can append to the URL the corresponding path, and say we wanted the player position. The transform component is a property of the object, so we simply append .transform, and then .position. The path can also match multiple objects. For example, to get the position of all the pickups. And we can also use wildcards to match names. So P* gives us all the objects with the name starting with P. Square brackets let us specify a where clause to filter objects from the results. Say we wanted all the pickups with an X positioned greater or equal to 0. Or alternatively, we could just put in a number to get a specific item. Sometimes it isn't convenient to know the exact path and names of objects in the scene, in which case we can use // to search child nodes. For example, to search the scene for objects named pickup, or with the pickup tag, or with the pickup component. So GQL gives you some flexibility to get data from your scene. But what if we wanted to change the state? We can assign values by appending an equals to the end of the query. So for example, let's change the rotate speed for some of the pickups. Or we could set the position of the player by passing in a vector 3. Similarly, we can call any underlying functions on the selected objects. Here we are calling the move_to function on the player component. Of course, you can do all this in the editor, but when you start thinking about automated testing, or perhaps the game is running on a phone, or in the cloud, then this gives you some interesting options. To make it even more useful, we want to watch variables in real time, or respond to game events. For this we need WebSockets. Unium has a simple WebSocket protocol. Messages are JSON objects that have a URL. The URL strings are mapped to functions just like the RESTful interface. In addition, messages can have an optional ID which is returned in the response. The game responds with the ID of the request and either some data or an error. So far this does not give you much more than the RESTful interface. However, with WebSockets you can repeat the query at a frequency of your choosing. For example, say we wanted to sample the frame rate 4 times a second. We add repeat with a frequency of 0.25. Or we could pass 0 if we wanted to sample the frame rate every frame, which we could graph if we choose. The other thing we can do with sockets is bind to events. Here I have an example that binds to the game debug events. So, finally, here's an example of an automation script that shows it all together. The script is using WebSockets to find and collect all the coins in the tutorial level. So if you made it this far, then thank you for listening. I hope you enjoyed this little tour of the library. Maybe it gave you some ideas for your own projects, and I would love to hear any feedback you may have. Goodbye.